Hello all, very welcome back after a long time, and this time we have got a very interesting topic that is to understand IC fabrication flow. That is an integrated circuit, that is an IC fabrication flow. So in this module, through the PowerPoint slide, we will understand how the IC is designed and eventually it is fabricated. So let us move to the next slide, which is on your screen. And you see this is a flow chart for the IC design process. So what you basically do is you start with the circuit specification. So let's say you are an analog design engineer or a digital design engineer or a mixed signal design engineer, or let's say radio frequency design engineer, that is RFN engineer. So as an engineer, you are given circuit specifications that is given by your manager or your company head, and your company has obtained a project. So let us say you want to design an amplifier. So if it is an analog design project, or let us say you want to design a microprocessor or a memory, for which also you have design specifications. Okay, so first step that starts is called as circuit specification. For example, as I said, for an amplifier, you are given to design an amplifier for a specific gain in decibel, for a specific bandwidth, for a specific noise, for a specific input impedance, for a specific output impedance, etc. There are multiple specifications, and your job is to meet those circuit specification when your IC will be fabricated, and it will be realistically made on the silicon. So here you see that a picture is of this wafer. This is a wafer on which multiple silicon chips exist, and each chip contains a final circuit that you design and fabricate. So first step, you are given a circuit specification, then you do and move to the next step, which is a hand calculation. So let's say, as I said, if it is an amplifier, so you use transistors to design that circuit. So you usually would like to start with the paper and the pen, and then let's say it is a simple differential amplifier. Then you have formulas to calculate the gain, bandwidth, 3 dB pole, frequency, noise, etc. So you do some preliminary hand calculations. Then you move to the next step, that is performing simulation. For this, you use electronic automation design tools, that is EDA tools. So you draw the schematic from the by picking up the various components used in the library. You place them on the screen of this tool, and then you interconnect these transistors together with the resistors. Capacitors are also there. So many other components are there, including diodes, and then you perform the simulation. For example, various analysis, AC, DC, operating point, etc. We have covered all these analysis, and if you want to see what these analyses are, you can refer to the different modules we have already performed and put up. Then you, through simulation, you try to understand, okay, my circuit is meeting the specifications, specs meet. Answer is yes or no. So if your answer is yes, whatever the gain you wanted of an amplifier, you see through it through the simulation. Whatever the bandwidth you wanted of an amplifier, you can see your simulations are showing up that. Whatever the input impedance or output impedance, etc., for example, noise in the circuit, you see that simulation is showing that at a first level. Then you say yes, you move to the next step, which is a layout. But what if your circuit specifications are not meeting? For example, you design an amplifier with a specification of 60 decibel dB gain, but your gain is like only 40 dB. through the simulation. Then look at this red line. You just go back to the circuit specifications because answer is no. So specifications meet no, come here. So again, you look at the circuit specification, you do some hand calculations again, modify the circuit parameters such as transistor geometry, some resistors, capacitors, etc. Again, perform the simulation. Again, you ask this question, is specification meeting now? If your answer is yes, then you come to the layout. Otherwise, you continue this cycle until and unless you see that the answer to the specification meet is yes. Then here is your layout. Then you move to the next state. After you draw the layout, again here, to draw the layout, you have a tool. From the tool library, you have various components like transistor, diode, resistor, capacitor, etc. You pick up those cells from the library of the layout tool, you place them on the screen, you interconnect them, and that is how your layout is. Then you simulate the circuit again with this time with the parasitics extraction because you have unwanted desirable parasitics such as resistances, capacitances that can degrade the performance of your circuit. And then you meet the specification. You ask this question again, you move to the next step. Is your circuit performing as intended, like the initial specifications? If the answer is yes, you are ready to move to the next step, that is fabricating a prototype. However, if your answer to this question specs meet, no, then look at this red line again. You go to the layout, you do some adjustment like again change the you adopt the different layout techniques. There are advanced layout techniques that helps you to optimize your layout to the to so that it will meet the specifications. And then again you simulate again with the parasitics, come back to this question, and finally you say that okay, now I can meet the specification. Then you are sending the prototype for a fabrication either in your lab of the university or your company for the prototype which offers the service to fabricate your prototype, etc. Then you move to the next step because when your design is fabricated for a prototype, you basically have the sample chips in your hand that is supplied to you by your clean room technicians or clean room manager, and you get those chips into a laboratory to test and measure the performance. And through the test and measure the performance, you again ask this question, that is the next step. Are the specifications meeting? Like, for example, you use different instruments and machines to test whether your chip is working or not, and you ask that okay, my gain amplifier was 60 dB, bandwidth was 1 megahertz, input impedance of let's say 10 mega ohm, etc. You measure this, and if you say okay, it is what was expected in the beginning, that is what was given to me as a designer. If answer is yes, you are all set and you send the chip or design for the mass production. Okay, and here it is like you see that this is how the mass production looks like. So this is, for example, 200 millimeter diameter wafer, and there are hundreds or even thousands of chips, or let's say hundreds of chips, and they are 90% of them are a good working prototype, so yield of the design is 90%. But what if in this question, if you say that specifications do not meet, so there are two no's. So the first red line takes you again fabricate the prototype because you made some mistake and the specifications are not meeting, and that mistake is out of because of the fabrications. So go and fabricate the prototype again. Otherwise, again, look at this red line. Then you go to the original starting point, that is the circuit specifications. Okay, and you have to do all these cycles again, like hand calculation, simulation, meet, and because the IC design has failed. So that's why only then you have to go and repeat the whole cycle. Otherwise, you have this midpoint fixes like fabricate the prototype, or maybe go to the layout again, fix the layout, or even right here, you go to the circuit specification in the beginning only after simulation. Okay, so hope you found this short, simple, straightforward model useful about understanding how the flowchart for the IC design process works. This could be a CMOS design process of the IC, this could be BiCMOS, etc. And with that, stay tuned for more engaging content like this. And till then, wish you happy learning.